So, okay. Thanks for coming and sorry for this fit. Yeah, and I hope that this talk probably can give you something more about WebAssembly because it's one of the technologies that actually it's how we can say it's very interesting to talk because we see next is give us very many capabilities to the existing web applications, especially with Node also. Um, so, okay, it's very introduced quickly about me. I'm developer, so Logic software, and basically also Linux user. And then I contribute some projects in the community, and also projects includes also Linux, a bit obviously NodeJS, Typescript, and Golang. Um, so what is included actually this talk is basically give you an introduction to WebAssembly, and then we see how we can use TypeScript with an end-to-end assembly. So then in the third part, we can see how Node.js or how we can use Node.js and WebAssembly together, and then compile TypeScript code to WebAssembly. So, very quickly introduction before to get it started with WebAssembly. It's this brief story regarding to the WebAssembly logo. This was very a bit old thread in GitHub. Even I did uh, participate at a very times ago, very years ago, a bit, but okay. The idea was to choose in the different proposals for the next logo of WebAssembly, and you see the community was very excited. Um, so then even you can see more creative ones. So, but the people was very exciting. Even we the community got some pretty interesting prototypes for the logo. So. Um, and then also in the end, the thread was very big, and the maintainer said, okay, this is a kind of a spam, so we need to stop that. So very quickly, so this did happen in the past. So just to mention that you can find very interesting ones and the original thread. So WebAssembly. basically, WebAssembly it's a binary format for taking advantage of existing languages, mainly at the moment, or officially support C and C++ and Rust, because both we see next both have no garbage collector, but with the exception that some ones can actually are coming, but we see next what exactly is happening. Also, WebAssembly we see is also called sometimes WASM. So, but exactly where is WebAssembly? WebAssembly is a binary format, and it works in a virtual machine in the same way like JavaScript virtual machine. And the idea is basically to take or to save all those values taken from the front-end languages, or we can say high-level languages like C or C++ or Rust, and then to try to take those languages and try as possible to compile, make optimizations and compile directly to machine code. The idea of WebAssembly is basically to offer a portable target for compilation, as I did said, languages like that you can see in the screen, and also describe, because it's an isolated virtual machine, describe and memory safe sandbox for execution. In that case, execute in the end WebAssembly code. So here's a diagram taken on one very interesting post by the Firefox team. Basically describe in that picture you can see the three main officially support languages, and the next step is to use an intermediate representation of those languages. I mean, taking the values or all the values included in those languages and try to create or try to represent in design those in some kind of a structure, and then take this structure, then make optimizations in the top, and then finally with a backend, we see what is backend, because the front end is the part of the languages. The backend is the part of the how we can transform those representations into WebAssembly code, and then to run directly into the specific architecture. So, but what are the advantages, or what are the capabilities of WebAssembly? Or calls WASM. So take less time. One of the important things is when you compile to WebAssembly, your code takes normally to fetch, for example, in the browser or loading from from NodeJS. We'll see later. It's normally fast because it's more compact than JavaScript. Remember that JavaScript is also sandboxed or in the top of PH, but also WebAssembly too. But WebAssembly it's something more more strict. We see then, and it's more more direct, more specific to the target, because we see later what we can compare with the JavaScript machine. So also decoding the WASM's binaries, the WASM calls in that case, it takes less time than parsing JavaScript, because WebAssembly adds some kind of a structure and add types definitions for helps to the compiler a little bit more quickly. And instead of JavaScript, the JavaScript needs to make many optimizations and many assumptions to optimize the code. And in that case, at first, parsing the code. So also the compilation, it's an optimization process takes less time because it's also wasn't very close to to the machine, or it's the target is deployed or is built binaries for running directly in the bare metal. So in that case, JavaScript, it's interpreter first, and there are also many phases. Then you code pass through for optimizations. Um, Also point to mention it's in comparison with JavaScript. JavaScript have a feature that is called de-optimization. This feature is the interpreter needs to parse the JavaScript code, but on the way, even after the compilation, probably can go back for optimize more, because we see then that the performance regarding to JavaScript is quite good, of course, but it's not as stable if we compare with WebAssembly. WebAssembly, the performance, it's more predictable than JavaScript, because JavaScript, we see then in one graphic how JavaScript is the process that it needs to pass through. Then other more points, that the JavaScript engine sorry, in that case, it was not JavaScript engine, it was the WASM engine. Sorry, this is wrong. The WASM engine doesn't need to make this kind of optimizations, because the intermediate representation that we see in the previous slide is very structured and very strict, and also is very focused on to make them the most less optimizations as possible, and then compile it directly. In that case, JavaScript pass many phases to like the optimization, because when you parse JavaScript and you compile it, it's possible to the compiler needs to re-optimize the code again. So even on the fly. Also other point is the execution often takes less time, because there are few compiler tricks and gadgets that the developer needs to know before to write consistently performant code. That means, in essential, you have a type system in the top of WebAssembly that give the grade of that is the compiler needs know to make some kind of assumptions as what value you are using, and then what value you plan to use next. It's very some similar to if you have the opportunity to see C++ or C or Rust. This was the reason, because the compiler in that case is more direct. Other point is the garbage collection is not required at the moment. WebAssembly doesn't support it. This is the reason, because you see the official support for 3 languages at the moment. Official support, I mean, because those 3 languages have no garbage collection. But in that case, at the moment, it's not required for those languages, because in that case, you need to manually or to deal with the memory manually. But garbage collector is plans to is in proposal right now, so I plans to add very soon, I think. So here you can see again how interact or how is the way of when the code incoming and was transformed to WebAssembly. Basically the same image previously, but we are mentioned to here this we have 3 main parts. One is the front end. The front end part, it's part of the high-level languages that you see in the screen. The middle part is basically the intermediate representation of those languages. because it's necessary to make a common interface in the middle for then to delegate into a specific architectures, because this higher interface can give that feature for compile and the compilation. The next part is the optimizations, and the wasn't compilation properly is basically called the backend. In the top of the backend, also again there are some optimizations for in the top of the WASM. So okay, compiling to WASM files, or in that case to WASM binaries. The compiler tool change, what I did mention at the moment with have more support. It's intended for use with these three languages, but under the hood is using LLVM. LLVM is a tool change for have to compile the code in the specific targets, and as possible to plug in some optimizations on the top, and but we will see then that there are other options, of course. M-scripting. So probably you heard about it, or you just see it in the community. This M-scripting is an independent project, but it's pretty interesting because offer a good and very easy interface for deal with for transfer or produce WebAssembly binaries. Basically, the project was intended to transform into the ISM.js, but then we see that there are other tools where we can use, even Typescript we can use for that. So basically here is the toolchain, or the compiler toolchain with one example, in that case here. You can see what is the process is on the fly. In that case, the compiler tail chains use, in that case C would be the front end with the C length, of course, and then the intermediate representation is basically the common interface between both after to compile into the binary. Here in that phase, the Web Assembly is used LLVM for optimized, based on that design, optimize the code and then to delegate to the backend. The backend part is basically the WASM compilation, I mean the WebAssembly compilation, and also there are options here like LLVM for compile WASM directly, or in that case, what I did mention in the previous slide, it's M-scripting. So okay, there's some other points. And normally the most enthusiast about WebAssembly, especially with WebAssembly modules, or the developers with coding languages like C or C++ or even in Rust, and then use that for compile to the WebAssembly binaries. So, but we see the next slides, it's possible right now to do the same probably with using TypeScript. There are two ways at the moment that I plan to show you today. One is WebAssembly test representations. It's basically the WebAssembly representation about I mean the text version of the WebAssembly. You can use this text format for coding your WebAssembly modules, or you can use the TypeScript. So WebAssembly, basically you see here an example that one presentation about one AutoCAD engineer showing us how powerful it's, in that case, WebAssembly, especially for existing applications or legacy applications. And basically, the engineer talked that was possible to reuse so legacy code written in C or C++, I think, yeah, C++, and then to deliver into the web. Using, in that case, WASM using M scripting in binary. Here are some kind of modules. Probably we can pick some ones for see what exactly is possible to do with WebAssembly. Probably can pick some of them. Yeah, probably you all did. So this is a project by Google. I don't know if this you probably knows, but it is using WebAssembly behind. The idea is to take in images and parsing and apply some optimization like apply codecs and change it formats and optimize the quality of those images. The particularity of that is the website use codecs, the codecs for images that actually are not available on the web. For example, you can see the image load into the screen, and the part on the right side you can see how we can optimize the size, for example, applied some compression in the top. In that case, for example, most JPEG is not available in Chrome, for example, but in that case it's possible because it's some library behind was compiled for using into the web. But you see here, I think I can click on it. So the the transformation or the optimization is pretty fast, and also this kind of code and behind is codes like Rust, some of them, and C++ for optimization, some parts. But you see, it is used. It's consumed in JavaScript, browser. So I will come back to the slide. So then we can see some other demos, but I think it's at the moment it's okay. It's pretty slow, I think. Okay, so then so it's time to talk about the TypeScript and WebAssembly. Yeah, okay. Basically, it's possible, but the help of WebAssembly script, it's on some compiler toolchain for compile JavaScript code into WebAssembly. The particularity is WebAssembly script compiles TypeScript in an strict subset. We can say. What exactly means a strict subset? Means basically a strong type system, because WebAssembly needs or works with a type definition behind, especially for integers or for arrays, etc. and it's necessary to be strict in that part because actually WebAssembly doesn't support a garbage collector. Also, it's a WebAssembly, assembly script compiles the Typescript code using binarian. We see binarian what it is. Before to explain you very quickly what is binarian, binarian is also an toolchain very with a very common interface for compiling TypeScript different targets, which includes some languages, and also JavaScript of course, but in that case it's something for help to assembly script to compile JavaScript. Basically, assembly script consists of those types. Those types are customized. It's part of the APA of assembly script, but it's perfectly matched with WebAssembly type system. If you see, for example, with integers, with unsigned integers, and so on. There are another special types for dealing with arrays, but at the moment we will omit. But if you are more interested for working with arrays or strict integers of arrays, you can take a look. So the next is NodeJS and WebAssembly. Now we did see that it's possible with TypeScript compiled into the WebAssembly, but how about Node.js? Because Node.js is basically in the top of BH. And if we thinking more about BH also includes WebAssembly. That means Node.js is also support. Even WebAssembly, it's coming in Node.js and is available from the version 8. And that means it's possible to use or to take advantage of that and use legacy languages or projects for specific parts or existing Node.js applications. And why should you use WebAssembly with Node.js? Basically, because WebAssembly gives us we can say a gate for delivered other kind of languages into the web. That case in Node.js, but independently of your CPU, independently of your operating system or virtual machine. If you compile it in WebAssembly, it's possible to reuse the same WebAssembly module and make it works in Node.js or in web applications. Also, there are binders layers in JavaScript. This basically, that allows us to, there existing APA for load those modules and to incorporate in existing JavaScript code or even reuse via the WebAssembly APA in JavaScript. And other reason is because WebAssembly is sandboxed. If you compiled your code from other languages, you don't take care about if your code is insecure because WebAssembly is basically a sandbox in the similar way to JavaScript VM. It means your code is only run in isolation and is only, we can say, protect and is running in an independent environment. So other reason probably we don't need to write C or C++ libraries in JavaScript. This was the previous presentation. For example, if we taking a look in further, we can see in the presentation of the AutoCAD engineer, he said, for us, it's probably very difficult or probably impossible to transfer all those existing libraries or software coding in those languages, in C or C++, into the JavaScript version. Instead, with WebAssembly, you can reuse it only. So there are some cases where probably it's not good idea or probably not really the rules really probably not really we can say not recommendable to use WebAssembly. You can take a look. For example, it's in general it's pretty fast. We see then that it's also fast than JavaScript in some parts, but the idea is not to compete with JavaScript performance, but the performance is in the side of specific targets. For example, for intensive processing. So in that case, WebAssembly is probably right or the good option to to use. What means not as fast as native? Because it's not completely native, because they are this is a virtualized in the top, but it's pretty quite fast. That means it in general it's very near to the bare metal performance. It's not possible with WebAssembly to reuse existing Node.js libraries, for example, or existing system libraries, for example, for getting access to the disk or to a specific hardware. I think I did see it. It's not recommendable because it's the intention of WebAssembly is to use for high performance computation. Also, there's no way or direct access from WebAssembly to Node.js, for example, for include Node.js libraries into the WebAssembly. Okay, we will take a look into the source code because I think it's also part to complement our talk. I don't know if we can move very quite faster, but we will try it. Yeah. Here have an example for try it. Let's try it. It's a kind of demo. Sorry, it's not WebAssembly, it's assembly script. So, okay. Basically, this example it's quite simple. The idea is to define a small module in JavaScript, sorry, in Typescript, and then to compile in WebAssembly, in WebAssembly modules, like a module in WebAssembly binary, and then reused in Node.js. So mainly this structure, you can probably can increase the font. I don't know if it's quite good for you or I think a bit more. Okay. So basically, the structure contains those directories. As possible, I did make that example quite simple. First, I would mention WebAssembly itself. This is a basic schedule generated with assembly script. I think we cannot change quickly into the browser for see the syntax. This is just a command line, one line to generate. But it's quite simple. Probably you can try it manually even. So so the first directory is called WebAssembly. Assembly. Assembly contains the TypeScript module in AssemblyScript. We're using the API of AssemblyScript. It's basically this one example shown in a function. But particularly here, it's something to describe here. It's the use this usage for integers. In that case, it's an integer 32, the 32 bits. But that type it's an API by AssemblyScript. So and then it's the normal syntax of TypeScript. Even you see it's quite similar. Even the way how you can export is basically the same. Then here in the type config is just using a type another config provided by the AssemblyScript. Nothing more, nothing complex. Sorry, I think my computer wants an internet. Okay. Then the next directory is basically that. So that means here is, and that place is your module, the WebAssembly module. And then the next directory is the building part. I mean, the building part contains your WebAssembly. Basically, here it's compiled the .wasm file. This file is the binary, the WebAssembly binary. I mean, it's not possible to read it. I mean, preview. I have a preview about. The second one is the .wat. This was generated. This is the text version of WebAssembly. And also assembly script generated for you the optimized version and the normal version. So I think the scroll is a bit slow. Okay. So next, the source directory. The source directory basically is I don't know if I can close it. Yeah. Okay. I think it's more quite good. So the next part is the source directory. Basically here I did create a bridge, we can say, the connection between between WebAssembly and NodeJS, because this file, this index.typescript is it's NodeJS. Basically here I am just defining on a quiet interface, a simple interface for my API. This very roughly contains one function, factorial. And then I load the WebAssembly optimized file in that case. Or also I can load the untouched file, of course. Here I resolve the path, which is very Node.js. The second line is I just reading and directly the file into the buffer, in one buffer. Then I used WebAssembly. WebAssembly class exists, and to the VM, what means it is in Node.js, so I can just call it and pass the buffer file. So then I call WebAssembly.module because I plan to use a module, or it's the assembly. My assembly script is a module, so wasm file, and then I have the wasm module. So then, sorry. Okay, I think it's good. How we can close it, this window. So this is okay. Then I define some very plain object called import. Basically, It's a way to receive an error if something error happen. Nothing complicated that. Um, but the point is here. The point is here, and the part of the function which said which I did create its get was an APA. Basically, is a simple function using the WebAssembly.instance. I mean, to create an instance of WebAssembly and then pass the module, and then I can pass options for handling the errors probably, and then notice the last part is I use it dot export. It is part also WebAssembly, but in that case I just roughly convert the type into. I mean, I applied my type of my APA, in that case factorial, as a result. If you see it here, the function returns was an APA. My was an APA previously defined in the top. And then I just export my function, that case a plain object, with function with APA, in that case factorial function. So nothing more. It's quite simple, but we see then how it works. Um, so then in the same directory, probably you are using this testing framework called Jest. It's or you can use another, but in that case I did use Jest. Pretty simple for testing my function. So here I did comment out. I can comment out. So basically here I am testing one result of my APA. Basically, you see its syntax, probably you know. There's nothing strange. But we see then how it works. So then I will go to the terminal. The terminal is basically we can see the package JSON. The package JSON defines these scripts. The first three scripts corresponds to assembly script. That means helps to you to compile WebAssembly code, and the third one is basically for generate the files and put together the first two, and then generate the WebAssembly binaries. And the third is basically the test that probably you know, and I will just run the script. In that case, I use jar, but you can use npm. Basically that. And the test passed, as you see, because yeah, I'm calling WebAssembly modules, native modules directly in Node.js. So it's quite simple. And I think it's nothing too it's nothing complicated. Probably you can deploy it. You can write to your models in WebAssembly using Typescript and then reused in Node.js. So basically that. Then in the package JSON, of course, there are um, uh, sorry, the APA. I mean the packages. Basically, the main package here is assembly script. For compile your script, it means you can use npm install or npm install your package, WebAssembly script, and then you can get it started to compile WebAssembly files. Nothing complicated. As you see, we can reuse existing WebAssembly code into Node.js. It's quite simple. Um, so unfortunately, I have not prepared an example in the browser, but it's not so complicated because the same syntax it's in the browser, except that you need to use fetch instead of use import. But the idea is basically the same. So okay, did you see WebAssembly now? On that case, we can take take a bit of what is the future of WebAssembly. There are very interesting proposals coming. One of them is the garbage collection support. Okay, the first one is I incorporate some of them because there are many, but exception handling is basically for C++ developers because what you need to have full support of C++ is necessary exception handling in the top. It's basically for that. But here a very interesting part is garbage collection support because it's an entry point for other languages and other more dynamic languages, even, for example, I don't know, Python, PHP, or whatever. And garbage collection also give us, or even Go, this was the reason because some of them are not available officially because also, okay, there are exist independent libraries that you can use, but officially it's not support. For example, Go is not support because it uses garbage collector. But this is pretty interesting. It's interesting feature. So also threads. Threads it's another important or pretty interesting proposal because it means you can take advantage of all your cores and your CPU, even in the browser in that case. Also, in my script model integration, in the same way that you did see in Node.js, then I use import my WASM file directly. The idea is to incorporate WebAssembly feature into the in the EmScript module or ESMS modules syntax into the browser for directly require the module independently. It's a JavaScript module or WebAssembly. Other interesting is web IDL bindings. It's basically IDLs is it's some feature for high optimization and eliminate the barriers between WebAssembly and the machine code or the JavaScript API. Sorry, because actually WebAssembly pass for some phases WebAssembly, and it's necessary to then pass an intermediate representation, then to pass through the optimizations, and then pass through the API. But the path is a bit long, so in that case, IDL proposed to make sure ensure the first step, and then directly to compile to the bare metal. So here's some recommendations about WebAssembly. Basically, if you are thinking on high performance parts or you plans to add for specific parts in your existing applications. So basically, WebAssembly is you plans to or you have or you plans to deliver some high computation, even in Node.js on the browser. You can use WebAssembly, or you can consider to use it because it's very intense for that cases. You see, in, if you can see, then the examples, many of them are 3D games or canvas rendering or images processing or complex algorithms that requires many CPU usage. In that case, probably WebAssembly is your choice. If you plan to interact with them, or with existing DOM, I mean the UI, the interface in your browser, mostly you can use JavaScript because, even some parts with WebAssembly, but JavaScript can do it at the moment well, because WebAssembly by default doesn't support them. Um, then if you plans to deploy it or deliver games also WebAssembly, you can use it for specific intensive parts in your games. All these you plans to use WebGL probably also is quite interesting to use. And but if you plans to use for websites or blogs, probably JavaScript is better or the choice by default. Um, so finally, some questions and answers. So basically, is your WebAssembly the JavaScript killer? They say the question. It's because the community normally or some people are arguing that Node.js, the WebAssembly is the replacement for JavaScript, which is not true because in essential it both works together, because the intention is not to replace JavaScript at all, but you can use it for heavy computation. You need to learn C or C++ or even Rust to work with WebAssembly. It's not really, because you can use how we did C, Typescript for that, but there are many others languages coming. Um, uh, Also, okay, it's also WebAssembly not the right choice probably with interact with DOM interfaces or with web components or something like that. Okay, I think that was all for now. And then in the last slide, you have all resources used in the presentation. Many of them quite interesting if you plans to go more in deep in WebAssembly, and also the slides are available and the code example. So, okay, I think if you have questions or something to mention or something to share, you can ask. So, questions, okay. Good.